1.
Okay, so let's talk about solving this problem. Just like we did in class, I got some questions I need to ask myself. Like, what is this graph? Y equals x. Well, y equals x, since it's a graph, it's a line, we'll have a y-intercept of 0, 0, and a slope of 1. Because think of it as y equals mx plus b. b is 0, slope is 1. That's pretty easy to graph. So I'm going to just sketch a quick graph of that on my axes here. So 0, 0, 1, 2, 3, yeah. So 1, 1, 2, 2, 3, 3. So basically I'm getting a graph that looks something like this. So there's y equals x. Now if I graph y equals negative x, that again has a y-intercept of 0, 0, but this time it has a slope of negative 1. So 0, 0 over 1 down 1 over 1 down 1. And I'm going to get a line that does this. The last line is y equals 6. Well, remember, y equals 6 is a horizontal line at 6. So let me go 1, 2, 3, 4. Whoops, I lost count. 1, 2, 3, 4, 5, 6. That's this horizontal line. Okay, well, I need to stretch this out because what we're ended up doing is making a triangle right here. And I want to know what the area of this triangle is. Let's think a little bit, because to get area of a triangle, area equals 1/2 base times height. I know my base and height have to make a right angle, so I need to know my right angle somewhere. And I think a little bit. Since this goes over 2, up 2, that's a right triangle with equal side. Oh, wait a minute. That's a 45, 45, 90 triangle. I know because these two are the same. An isosceles right triangle. So that means that this angle here is 45, and the same is true there. That's 45, which means that creates a right angle right there. Okay? Nice thing about the y equals x line and y equals negative x line. They're going to be 45 angled lines. Okay? Think of it like that. They create 45-degree angles with the axes. Okay? Which means here's my base, there's my height. Now, what other information do I know? Well, since this is the line y equals 6, look where it intercepts. It's going to intercept at 6, 6, and it's going to intercept at negative 6, negative 6. Because these points have to be on those lines, right? This is on the line y equals x. So if the y equals 6, the x has to equal 6. If the y equals, positive 6, my y value is positive 6, isn't it? If the y is positive 6, then the x is negative 6. Okay, so that's just how this works out, which means this has a length of 12. This triangle, these two are the exact same. I've created yet another 45, 45, 90 triangle. These are 45-degree angles. That means that I can find these using my special right triangles. I'll say the base times radical 2 has to equal the hypotenuse. So the base equals 12 over radical 2. Remember, we want to rationalize that. So when I rationalize that, I'm going to get 12 radical 2 over 2, 6 radical 2 is my base and my height. Okay? Now I can take that and put that into my area formula. 1/2, 6 radical 2, 6 radical 2. So that's 1/2, 36 times 2. 32 and a half are going to cancel each other out to leave me with 36. There is the area of my triangle. So again, it's solving a problem using some knowledge we know from geometry, using the idea that I can find 45, 45, 90 triangles. I know it's there. I'm not guessing. I know that that's an equilateral or isosceles right triangle. So that's a 45-degree angle. So that's another 45 on that side because my axes come together to make 90. So there's my 90-degree angle. I also know that these two are going to be the same length, and that's my hypotenuse. Okay, so looking for little tricks like that help you with these problems. Take a look at the answer to the next problem too.